Okay, I'm going to do page 2 now. This kind of shows through from the other side, but that's okay. We're going to work with a quadratic graph. This is a good piece of advice to label these points. So to get here, I had to go back 2 and up 4. To get here, I had to go way back and then down very far. So that's negative infinity is that ordered pair. And then to get over here, it's like you have to go very far over. Remember, we're thinking about the end of this arrow. Very far over and then way down. So that's infinity, negative infinity. That's my second point. That's a negative, not a positive. Okay, now that I've done that, now I'm ready to answer the questions. So when I do domain, I like to take the 2 blue pieces of paper. Here's one. Whoops, where's some blue paper? Uh-oh. I like to take 2 blue pieces of paper and make like a sandwich with the graph. And so I'm going to put the pieces of paper down here. And what I notice is that on both sides, I'm hitting arrows. So when I'm hitting arrows on both sides for the domain, that means the domain is from negative infinity to infinity. And then for the range, I'm going to put these on the bottom, right? Again, I'm hitting arrows down here. So that means this graph really goes on to negative infinity. And this is the top of the graph. The top of the graph is at 4. I'm looking on the y-axis to see that. So the graph goes from negative infinity up to 4. From negative infinity up to 4. And it includes the number 4. I'm making a video. So. Okay. When I do my interval of increase, right, that's on the roller coaster. So the roller coaster has to go from left to right. So this is the uphill part of the roller coaster, and then this over here is the downhill part. So my increasing part is this part. So I'm going to cover up the other part and ask myself, okay, what is this section of the graph? Well, it starts at negative infinity and it goes to, I'm looking right here, negative 2. So from negative infinity to negative 2. And then the downhill part, the decreasing part, if I put the paper here, again, I'm able to look right here, is from negative 2 to infinity. You can also do it by looking at the ordered pairs. It's from negative 2, this is the x part, to the last ordered pair is infinity. So from negative 2 to infinity. Okay, here are my x-intercepts. Boom, boom. Negative 4, 0, and 0, 0. And my y-intercept is actually the same as my x-intercept. It's 0, 0. To answer the question about end behavior, that's why I labeled these points. So as x approaches infinity, that means I'm looking over here. What happens to f of x? What happens to y? It goes towards negative infinity. And as x approaches negative infinity, f of x also approaches negative infinity. That's why we have that labeled. Negative infinity. Okay. To do my vertex form, I like to kind of set it up like this, to kind of fill in the blanks. So what I see is that the graph went to the left 2. So I'm going to make that plus 2, because that's the one that's opposite what you think. And then up 4, plus 4. I also see that the graph flipped over, so I know I need a negative sign here. But I see that it follows this basic pattern of over 1, down 1, over 2, down 4. So it's really, if you want to put a number here, it's negative 1. You could put the 1 or not. But we definitely need the negative sign, because that's what causes the flip over. Okay. And now for some factoring. When we factor, all of these problems, you always want to look for GCF first, and then we'll make the x and do the factoring. I'm going to do all these problems with the magic x method, but that doesn't mean that you can't use your box method to do the same problems. Okay, first I look for GCF. There isn't one, so I set up the x. Factors of negative 18 that add up to negative 7 are negative 9 and 2. This is a standard problem because that's a 1, so I'm just going to take those numbers and bring them over. And of course, you can check this by foiling. This says do not solve. These are not equations. They're expressions. All you have to do is factor them. Okay, I look for a GCF. There isn't one. Set up the x. This is an advanced problem because there's a 2 here. 2 times 10 is 20. Factors of 20 that add up to negative 9 are negative 5 and negative 4. Now, because this is an advanced problem, I have to do my magic x. I'll divide both of those by -4. This one can't be simplified, so I'll just leave it. This one can become -2/1. And then I'll write my factors. The first factor is 2x minus 5. The second factor is x minus 2. And again, you can check this by foiling. That's what I'm doing right now in my head. I'm foiling to check it works. Okay, weird one. This one only has 2 terms. First of all, I didn't do it. Check for a GCF. 36 and 25, there's no GCF. Any of these 2-term problems, I'm thinking, hey, maybe this is the difference of squares. And I'm looking, hey, 36 is a perfect square, and so is 25. That means it's going to take this very kind of familiar structure. First, I think about 36x squared. How do you make that? 6 times 6. How do you make 25? 5 times 5. One gets plus, one gets a minus. If you want to check that, what happens is that the middle terms cancel out. This is the check. And you get 36x squared. Outer term is minus 30x. Inner term is plus 30x minus 25. And these cancel each other out. And you're left with 36x squared minus 25. Okay, next up, I'm going to look for a GCF first. And I see for the numbers, I see 2. And for the variables, I see that they all have an x. So my GCF is 2x. And then it becomes 2x squared minus 3x minus 14. Now I'm not quite done because that is actually also factorable. So I'll make an x here. Factors of, and it's advanced. Whew, -28. That add up to -3. That's -7 and 4. Because it's advanced, I'm going to divide by 2. That's the leading coefficient. Now, it's very tempting to divide by 4 because you see a 4 up here, but we're working, at this point, this 2x over here is just going along for the ride. My focus is on this problem right here, so that's why I want to divide by 2. This one becomes 2/1. This 2x, again, is just going along for the ride. And I'll do 2x minus 7, that's my first factor, x plus 2. That's the completely factored form. And I will try to, check that a little bit. Okay, next, I look for a GCF. Ooh, 15, 19, and 6. No GCF. So I will make an x. At the top is 15 times 6. Ooh, 15 times 6. Well, 15 times 6, so that's 90. Oh, this isn't as bad as I thought. Factors of 90 to add up to 19 are 10 and 9. And then you're going to divide by 15. And simplify. Seems like I need a smaller pen to do some of these. When I simplify 9/15, 3 goes into both of these. That becomes 3/5. And 10/15, 5 goes into both of those. It becomes 2/3. So my 2 factors are 3x plus 2, 5x plus 3. And you can check it by foiling. Next problem, I'm looking for a GCF. Again, there is no GCF. So I set it up. It's an advanced problem, -12 and 11. Factors of -12 that add up to 11 are 12 and -1. Divide by 3, because that's the leading coefficient. This is simplified already. This one becomes 4/1. My 2 factors are going to be x plus 4 and 3x minus 1. And I'll check it in my mind by foiling it. Looks good. Okay, next one, we look for a GCF, and it does have a GCF. For 9 and 24, it's 3 is the number part, and they both have an x, so 3x. 3x, this becomes 3x minus 8. Now, it's really tempting to keep going with this, but this is a linear factor. You can't factor that anymore. The only ones that you can factor again are the ones that are quadratic. Like this one, we could factor that again. This one we can't. It's finished. Next, 12x to the 4th power, 75x squared. Again, I start with a GCF. I'm like, okay, 12 and 75. What do they have in common? They both have a 3. And x to the 4th and x squared, they both have x squared. So I'm dividing by 3x squared. That's my GCF. That goes out here. Inside, I have 4x squared minus 25. Okay? Now I have a problem a little bit like this one, where I have two perfect squares, 4x squared and 25. 3x squared goes along for the ride. 4x squared is 2x times 2x. How do you make 25? 5 times 5. One gets a plus, one gets a minus. That's another difference of squares problem. Remember, after you bring out the GCF, you don't have to really pay any attention to it. You're only working on what's in the parentheses here, and that becomes 2x plus 5, 2x minus 5. Okay, last one. I'm looking first for a GCF, and there is a GCF. It's 5 is the number part, and they also each have an x. So that goes out here. And then what's left inside is x squared minus 7x plus 1. Right? 5x over 5x is 1. You got to put something there. And then I'll set up an x, and it's 1 on top and negative 7 on the bottom. Factors of 1 that add up to negative 7. Well, there aren't any factors of 1 that add up to negative 7. So this doesn't happen very often, but this quadratic portion here is not factorable. So you just leave it like that. That is the most factor that we can get this one. Some of the others we're able to factor again, like this one. But for this particular problem, we can only go this far and then we stop.